Just wait for 2 minutes. Okay, let's move to the next question. Question number 7. Okay, you can hear me, right? Someone?
Yes, sir.
Okay. Question number 7. Two blocks, equal masses. Surface of A, that's block A is smooth, but that of B has a friction coefficient 0.1 with the flow. Block A is moving with a speed of 10 meter per second towards B, which is at rest. So U2 is 0. Find the distance traveled by B if collision is perfectly elastic, that's E equal to 1. And B, collision is perfectly inelastic, that's E equal to 0. Take G as 10 meter per second square. Straightforward question. So just before the collision, the energy of this system, because these are two equal masses, right? So you can straightaway use the result that two equal masses, if they collide after collision, if it is elastic collision, then the velocity get interchanged. So since the B is at rest, so after collision, A will come to rest and B will move with the same velocity as 10, just after collision. After that, something will happen, but just after collision, there'll be velocity interchange. So initial kinetic energy just before the collision is half m V square of the A block. B is at rest. And finally, when the block B comes to rest because of friction, that time the work done will be the friction force in the distance traveled. Okay, so finally the block will come to rest. So the work done in the process when the block B moves from its initial point to the point where it's coming to stop, that work done during the duration is the friction force in the distance traveled. So this entire initial energy will get dissipated in this work done against the friction. And this friction force is mu to the normal reaction. It's a vertical horizontal flow, right? So the normal action will be m into g of the second block. So friction force is mu into m into g, mu into n is mg, and the distance traveled d. So m will cancel because equal mass. Okay, from this I can get the d as 50 meters. This for elastic collision. If the collision is inelastic, I have to get the final velocities of A and B. Okay. Initial momentum of the system is m into 10. Final height. Inelastic collision means they will stick together after the it collides because E is 0. E is 0 means final relative velocity is 0. That is both are sticking together. So final momentum means the two masses sticking together, which is 2m, and will move the common velocity B. So the common velocity is 5 meter per second square. And this both A and B are moving together, but only B will feel the friction force. So the friction force is mu to n, but n is only due to the B block, not the first block. So the friction force is only between the block B and the floor. So that's why the normal direction is mg, not 2mg. This is an important point. Okay, even though block A is moving, there is no friction force on it. So the friction is only between the block B and the floor, which is mu normal reaction due to the block B, which is Ng. Okay, and initial energy just after collision is half 2m into V square. This will not match with this half mv square because in the there will be some heat generated. So I have to compare the energy just after collision to the work done against the friction. Because after this end of this work done, the velocity will be zero. So the total energy of this one is gone into dissipating this work done against the friction. This was the important point. The energy just after collision is gone into the work done. So from this, I'll get the distance as 25 meters. Okay, so for elastic collision, it's going the distance of 50 meters. When the collision is inelastic, both are traveling together and they cover a distance of 25 meters. So the option is A and B. A for elastic collision and B for inelastic collision. Is this clear?
Yes, sir.
Okay. Question number 20. Correct. Question number 8. Question number 8. Non-zero external force acting on system of particles. Velocity and acceleration of center mass found to be V0 and A0 at instant t. It is possible that, see, once external force is there, external force equal to mass and acceleration of center of mass, and mass is the total mass of the system. So since external force is non-zero, A has to be non-zero, so acceleration has to be non-zero. So there's only one option which is matching that, that's option B. But in the key, they are given D, which is not correct according to me, and I raised an objection to this. D, it says A is zero. That's not possible because force is non-zero. Okay, so correct option is option B. Is it clear? External force.
Sir, I can't understand how can you tell it.
No, they are given non-zero external force, right?
Yes, sir.
And external force is nothing but mass into acceleration of center of mass. Okay,
Yeah.
and mass is so A has to be non-zero. Okay, so there is only one option which has for non-zero acceleration, which is option B. Okay, and maybe that option D is A not equal to 0 and B not equal to 0. That way, B not equal to 0. Option B says B naught is 0. The center of mass is not moving. Once acceleration is there, center of mass will move. It's at a given instant, it can be 0. At a particular instant. Okay, at instant time. Okay, so if option D is like A naught not equal to 0, then
Sir, V0 will also be not equal to 0 and A0 will also not equal to 0.
see, acceleration 0 means that means that change in velocity is not 0. But velocity can be 0 at some instant, right? See, for example, just a minute. For example, from the Earth's surface, I'm throwing a mass. Okay, but at any instant, the velocity, there is acceleration, right? G, which is downwards. But this go up and at the topmost point, turn back, right? So at this point, the velocity is 0. Okay, that does not mean there is no acceleration at this point. Okay, so just before that velocity is something, just after its velocity is something. So acceleration not 0 means change in velocity is not 0. So the velocity can change from 0 to 0.1 or from minus 0.1 to 0. Okay, but it can be 0 at some instant, like this one. At the topmost point, the velocity is 0, but acceleration is still there. Okay, that's what the option B says. Velocity can be 0. At the instant, the acceleration can be non-zero. Okay, and the fourth option, if it is like A not equal to 0 and B not equal to 0, then option D will come.
So option B and D will come, right, sir?
Option
B and D.
If D is in the D, if they put A not equal to 0, then option D is correct. Because option C and D are exactly same, right? option C and D in the question is exactly same, but option D should be like A naught not equal to 0. That way option B and D are correct. Understood the mistake? No. The mistakes in the question, option
sir.
B, A naught should be not equal to 0. So with A naught not equal to 0, both B naught 0 and B naught not equal to 0 are possible. Like at this point, here, velocity is upward, but acceleration is there. But the topmost point, the velocity is 0, but acceleration is there. Okay. So acceleration non-zero means velocity can be 0 because just after the instant velocity can be some value, and after value some value. Only change in velocity is not 0, but velocity can be 0. Okay.
Sir, then C will no come, sir.
D, if the question is like D will come if A naught not equal to 0. So it's a sort of a typo mistake in the question. So option D is true if they have printed it correctly like A naught not equal to 0. So I would say if correct answer for this question is only B, as is at least in the question paper. Okay, we'll move to the next question. The ball hits the floor and rebounds after an inelastic collision. In this case, momentum is always conserved. Energy is not conserved in inelastic collision. So momentum of the ball just after collision is same as A is true. What is the answer for? Hold on. Ball hits the floor and rebounds after inelastic. In this case, momentum of the ball just after collision is same as just before collision. Not just the ball, momentum of the system. Momentum of the system is conserved, not the individual objects. Here the collision is between the ball and the floor. So momentum of ball plus floor. If I take full thing as a system, then momentum is conserved. In the case of
Sir,
floor,
in inelastic collision, kinetic energy won't be conserved, right, sir?
yeah, some heat will be generated.
So option D won't come, right, sir?
Option D, total energy. Yeah, strictly it will not come. But if they say it's where is it inelastic? Okay, inelastic, no. Fine. But if say total energy, and in the total energy, if they include this heat energy, okay, then it is conserved. Kinetic energy is not conserved in inelastic collision, but total energy, if you include the heat as a form of energy, then it is conserved. In that sense, D is true. See, option B says mechanical energy, right? They said mechanical energy, then it is not conserved. It's kinetic energy. Okay. But total energy is conserved. Option B, mechanical energy, the ball will change because mechanical energy, the system may be conserved. Total movement of the ball and total movement of the ball is conserved because it's the entire system. So C is true and D is also true because if you input the heat energy in the total energy, then it will be true. Okay, 9 is C and D only. Question number 10. Head-on elastic collision, the bodies of with equal masses. This you already know the result, right? Velocity will be interchanged, speed also interchanged, momentum is interchanged. Faster body slows down and slower body speeds up. Yes, that is true. For example, this one. Two identical bodies, same mass. Okay. Suppose this thing is moving with say 5 meters per second. Okay. And this thing is moving with say 2 meters per second. So after collision, this second body will go with 5 and this thing will slow down to 2. Okay. Only then the second collision will not happen. And if it is like this thing is going with 5 meters per second like this, and this thing is coming this way with 2 meters per second. After collision, this first one will go towards left with 2. Okay, and the second will go towards right with 5. So there is interchange of velocity. So whichever is faster will go slower, and whichever is slower will go faster. This is question number 10. Speed is momentum is faster body will slow down, slower body speeds up. Okay, so 10 all are correct. Is it clear? Question number 11. A block moving in A breaks into two parts and the parts separate. Total momentum is conserved because there is no external force. Momentum is conserved. Kinetic energy is not conserved. Total energy can be conserved. Total kinetic energy, because when it's breaking, we don't know what's going to happen. Is it some chemical energy? Total momentum must change. No, it will not change. Total kinetic energy must change. It could change because if there is some form of energy, total kinetic energy must change. Yeah. So basically, how will it break? It will break because of an explosion, right? So once they explode, definitely there will be some form of sound energy. Okay. And maybe some chemical reaction is there. How will it explode? Okay. So other forms of energy are there. So if consumed kinetic is part of the total energy, which may or may not change. It must change because initial energy is kinetic energy, and the final has got some other forms of energy. So D is also true.
Sir, I can't understand why kinetic energy is not conserved in inelastic collision.
Because there are, just think whether other forms of energy. See, when collision happens, definitely there will be sound, no? Explosion, right? Yeah, it's breaking into two parts. Okay. So how will an object break? Maybe some
Sir,
chemical,
not always it breaks it. Sir.
not break because of stress.
Always it.
Okay, at least there will be some sound, right? When it breaks. So some form of energy
Yes,
is going
sir.
as sound energy.
Yes.
So if you consider only sound energy and kinetic energy, obviously kinetic will drop a little bit. Okay. So strict statement is total energy is conserved, not individual energies. Okay.
Sir, in elastic collision is conserved. Right?
Elastic collision, yes, it is conserved.
There also there might be a sound reason.
Yeah. Then that way it's not strictly elastic. That way no collision is strictly elastic. Because some small amount of heat will be created or sound also will be created. But if you neglect that, it's an ideal situation, right? In that case, it's elastic collision. Okay.
Okay.
Elastic, there is no other forms of energy. Can easily be conserved. That's ideal
Okay.
situation. Question number 12. Point mass 1 collects elastically with stationary mass 5 kg. Okay. 5 kg. After collision, 1 kg reverses direction. There I put minus sign here. U1. 1 is for the first object. V is the final velocity. -2. Which of the following statement is correct for the system of these two masses? First option, momentum of the system. Momentum will be conserved. So what is the initial momentum? Total momentum of the system. Initial momentum is what is the initial resource is not given, right? So we have to find the velocity. Fine. So then after collision, we can find the velocity using the formula. This formula for perfectly elastic collision. Sorry, inelastic collision, partial elastic. This for elastic collision. First one, where they have put E equal to 1. Okay, using this formula, I can get this is at rest, right? So only the first term will come. So the first one is difference of the masses -4 by the total mass 6 into U1. Okay, that is some into U1. So only V2 is twice the first mass by total mass. Twice the first mass is 2 by total mass is 6 into U1. Okay, so I got the final velocities of both V1 and V2. Okay, and V1 has been given as -2. So if you use that -2 here, I'll get U1 as 3. Okay, because this is being given in the question. The final velocity of the first mass after collision is -2. So if I use -2 here, I'll get U1 as 3. So once I know U1, I can use it here to get V2. So collision of the second one after collision is what? Towards right. Okay, and initial momentum I can find once I know U1, it's 1 into 3. And that is the same as the final momentum because momentum is conserved because there is no external force. Or I can also calculate using this final velocities. Final velocity 2 is 1. So and the final velocity of 1 is -2. So 1 into -2 is -2 plus 5 into 1, it is 5. So it is the same thing. But you can just confirm momentum is conserved. Okay, so total momentum is 3, which is option A. So option A is true. Okay. Option B, momentum of 5 kg mass after collision is 4. After collision, 5 kg mass moves with 1. So its momentum is 5. So option B is wrong. Because it says momentum is 4 of the 5 kg mass, which is 5. 5 into 1, which is 5 actually. Okay, so B is false. And C, can give center of mass, which I didn't get it. Okay, so initial kinetic is kinetic of this mass, first mass only is half m, just 1, and then velocity square is 3 square, which you found out here. So initial kinetic is 9 by 2, 4.5 joules, and kinetic of center of mass is, I have to find the velocity of center of mass. I have to half m v square, where v is the total mass and v is the velocity of center of mass. So the individual velocity, I can get the velocity of center of mass as 3, use the initial velocity, and I can also use the final velocity, which is 3 and minus 2 and 1. If you use minus 2 and 1, I get minus 2 into 1, that's minus 2, plus 1 into 5, that is plus 5. Okay, by the total mass, that is 3 by 6, that's half. Velocity of center of mass initial is 3, right? So after initial velocity of center of mass is 3, if you use the final velocity, it is minus 2, and then this is plus 1, right? So minus 2 into, this one is minus 2 momentum, and then 5 into, is plus 3, yeah. Final moment is plus 3 only, which is same as the initial moment. V1 is minus 2, okay, and V2, it's V2 is plus 1. Okay, so final momentum is minus 6, minus 2, plus 5, so it's plus 3 by the total mass, it is 6, so it's half. Right, I'm making some mistake. Here I calculate final momentum. It's minus 2 into 1 plus 5 into, just the final momentum, right? It's not divided by total mass. So final momentum is 3. Okay, momentum is velocity of center of mass in the first case is 3. Okay. And velocity of center of mass should not change, right? What is the final velocity of center of mass? Velocity of center of mass final is m1, the final velocity of the first one, plus m2 v2 by total mass. M1 is 1 kg, and the final velocity of 1 is minus 2. So 1 into minus 2 is minus 2. Plus the second mass is 5, and the velocity of the second mass after collision is 1. So it's plus 5. Momentum is plus 5. Where the total mass is 6, right? So it is 3 by 6. That is half. So center of mass is this is a there is no external force. Okay. How is velocity of center of mass changing then? Okay, initial velocity center. I made a mistake in this initial velocity center of mass. Initially it's I made a mistake there. Okay, this is final. Initially it is I made a mistake there. Initially it is m1, which is moving with the velocity of u1 is 3, right? So 1 into 3, 3. That's a mistake I made. Okay, so it's m1 is 1, 3, m2 is at rest. The total mass is 6, so it is half again. Okay, so kinetic energy of center of mass is half m v square, but this total mass Okay, and this velocity is the center mass velocity. So it is half. Total mass is 6 into velocity of center mass is half square. Okay, so this is 6 by 8. Okay, that is 3 by 4.75. Ah, it's correct. Option C is correct. Okay, I made a mistake here. So A and C are correct. So I think the given key is correct then. Is it clear? The mistake I made is this one. Velocity of center mass is 3. I took as 3, which is not correct because velocity of center mass, the initial one also, the first mass, which is moving the velocity of 3, plus I have to do this one and divide by the total mass. So if we do that, I get the velocity of center mass as half, which is similar to the final velocity of center mass. So instead of that, I took the velocity of center mass by mistake as 3. Okay, so with this thing, I didn't get the option C. But if I do the thing correctly, with velocity of center mass as half, then I get the kinetic of center mass as 3 by 4, which is 0.75. So option C is correct. So the key is correct. So 12th one, the answer is A and C. Is it clear?
Yes, sir.
I'll move to the next one. Question 13. Ball impinges directly on another ball at rest. The first ball is brought to rest by the impact. Okay, so V1 is 0. Half the continuity of loss by the impact. The value of straightforward question. M1 and M2. Initial velocity of 2 is 0. And final velocity of 1 is 0. After this thing hits, this thing comes to rest. And final continuity is half of the initial continuity of the total energy of the system. Half the continuity is constant. So the value of M1 by M2 is. Okay, so again, I can use that formula to find the final velocities after collision. This one. Okay, and there is a E is kinetic is lost, right? So it's a inelastic friction. I will use this formula. Okay, so V1 I'll get as M1 minus EM2 by total mass into U1. This second term will not come because second mass at rest to start with. So U2 is 0. So only the first term will come. So first one V1 is M1 minus E times M2. So M1 minus E is only the total mass into the initial velocity of the first one. And this is equal to 0. It's given in the question. From there, I'll get E as M1 by M2, the ratio of the masses. Okay. So, and then V2 using the formula is 1 plus E by total mass into M1. 1 plus E, which is by the total mass in M1 U1. And E I found as M1 by M2. Okay. If I put that, I'll get it as E times U1. Okay. So I got V2 in terms of U1. And they are given this one. Final kinetic is half the initial kinetic energy. So final kinetic energy is half M to V2 square, which is E V1 square. Because the first mass is coming to rest, it's given in the question. And initial kinetic is of the first mass only, because the second mass is at rest. So this ratio is given as half. And I know this was in terms of U1. So from this I get the ratio of M1 by M2 as half, which is 4 by 8. So the correct option is option. Sorry, the value of N is 8. It's an integer question, numerical value. Okay. Is it clear? Question number 13, right? Two mass are colliding. This is at rest initially, and after collision, this one comes to rest. And there is a loss of kinetic energy with final kinetic is half the initial kinetic because they have said half the kinetic energy is lost. That means that final kinetic is half of the initial kinetic. I find the ratio of the masses. So if I can find V1, okay, using that formula and put equal to 0, I'll get V as M1 by M2. And I can find V2 using the formula, and I'll use E as M1 by M2. From this, I'll get V2 in terms of U1. And ratio of the kinetic energy, KF by KF is half. Okay, from this, I'll get the value of the ratio of masses as 8. So next question, question number 14. I think with this we'll close. Okay, question number 14. A body of 3 kg correlates elastic with another body at rest. So that is U2 equal to 0. As soon as you read the question, put the information in the question in terms of symbols. U stands for initial velocity and 2 stands for the second mass. So U2 is 0. Okay. And then continues to move in the original direction with half the speed. That is the first mass, right? The body of 3 kg correlates elastic with another body at rest, and then continues to move in the original direction. That is V1 is U1 by 2. What was the initial velocity? Reduced by half. This is given the question. Okay. Find the mass of the target. We have to find this mass. The same we have to find. And say elastic position. So E is 1. So all the information in the question has come in this figure in terms of symbols. Okay. So momentum is conserved. Initial momentum is 3 U1. Final momentum is 3 into U1 by 2. Actually 3 V1, which is U1 by 2. And then M into V2. So this is one equation. And portion of distribution is minus final relative velocity by initial relative velocity. Final relative velocity is final U1 by 2 minus V2. And the initial relative velocity is U1 minus 0. Okay. And this is equal to 1. So from this I'll get U1 equal to minus U1 is gone here and this minus and I've taken it here. So minus, we make it minus U1 by 2 and this minus into minus will become plus. So plus V1 by 2. So from this I'll get V2 as 3 by 2 U1. Okay. So V2 in terms of U1, if I put it here, U1 will cancel and I'll get the mass. Okay. So V2 in terms of U1, if I put it here, I'll get 3 U1 and this 3 by 2 U1. If I take it here, I'll become 3 by 2 U1. Plus m times V2 is 3 by 2. So from this I'll get mass as 1 kg. Okay. So the answer for this question is 1. Is this clear? No doubts, right? Just the momentum conservation and definition of V. Shall I go to the next question? One more.
Yes, sir.
Question number 15. A particle loses 25% of its energy during collision with an identical particle at rest. So two identical particles M and M, and this is at rest. So initially the velocity is 0. Let the initial velocity of this thing be U, and after collision, let the velocities be V1 and V2. Okay, and it says 25% of the energy is lost during collision. Okay, so momentum conservation, initial momentum is M into U, final momentum is M V1 plus M V2. M will cancel, so we'll get relation U equal to V1 plus V2, one equation, and energy is lost, right? So initial final energy is V1 square plus V2 square. That's actually half M V1 square plus V2, and that half M V2 square. And right side the mass is also half M initial velocity square. That is half M U square. And the final energy is 20% energy is lost. So that means Kf is 3/4 of Ki. Okay. So that's why the initial final energy is half M V1 square plus half M V2 square. That is 3/4 of half M U square, because the second mass is the energy is 0 because it's at rest. Okay. So from this, I get another relation between V1 and so two equations I have. This is the first one. Two unknowns are V1 and V2. Okay, here second equation I have two unknowns V1 and V2. So from the first one, I can eliminate V1. V1 I can write as U minus V2. So V1 is written as U minus V2. So this is a quadratic equation in V2. Okay, so I can rewrite this thing as this one. Okay, so this if I solve it using the minus b plus or minus b square minus 4ac by 2a. Okay, I'll get some term here and this one. And what I want is V2 minus V1 minus V2. So that way this term will cancel. So only this term for one version will plus, another version will minus. So if I do V1 minus V2, what I'll get is twice of this square root. And that 2 will cancel with this one. So V1 minus V2 will just be the square root this one. So that thing is this is U square minus U square by 2. So it's actually U square by 2. and u, so if it comes to become u, so then we just square root of half. So what will remain is u by root 2. So v1 minus v2 is u by root 2, and quotient which is defined as the final relative velocity, which is u by root 2, by the initial relative velocity is u minus 0. So it's 1 by root 2. Okay, which is points, and they are given in the question as 1 by root n. So the value is n equal to 2. Okay. Is it clear?
Yes, sir.
Okay. So 15 questions have been done. Only 3 are remaining. Okay, let me go to the next one, 16. A bullet of mass 110 kg. Bullet will look like this. Okay, we'll draw figure properly also. 110 kg moving the speed of 50 meter per second. It's a mass capital M of mass 1 kg kept at rest. So V2 is 0. Okay, small part of the ball of mass 110 kg, that's here. Okay, it breaks and then sticks to the bullet. So this is the bullet, and the small part of this M, 1 kg has got stuck to it. Okay, and that mass is given, I think, as 110 kg. So this is 110, this small part of the ball, this is 110. So the remaining ball will be 910 kg. Because initially it's 1 kg, so 110 has got stuck here. So remaining 910 will move some speed. Okay. And the remaining ball is found to move at 2 meters per second. So this remaining part is given the velocity after it hits its 2 meters per second. Okay. And in the direction of the bullet, so it's moving towards right. So velocity of bullet after collision, that we have to find out. Straightforward question. So momentum is conserved. Initial momentum is 1 by 10 into 50. This is at rest. So there's no momentum from here. Only momentum comes from the first one. That's the final momentum, which is this is 2 by 10 because 1 by 10 of the bullet and 1 by 10 of this broken mass. So its total mass is 2 by 10, and it moves the velocity of the bullet, final velocity of the bullet, plus the mass of this remaining ball, which is 9 by 10 into 2, which is given in the question. Okay, from this I get the velocity of the bullet as 60. That means n is 2. Okay, 17, it's a bit complicated. I'll go to the 18th one. 18th question, the body of 3 kg moving the velocity of 4. Okay, collides head on with another body of mass 4, moving the opposite direction, velocity of 3. Okay, after collision, they stick together. Okay, and move with the common velocity, which is, so initial mode of the system is 4 into or 3 into 4 plus 4 into minus 3, because velocity I have to give a direction. If right is positive, means this velocity is minus 3. So initial mode is 3 into 4 plus 4 into minus 3, which is 12 minus 2, which is 0. So initial momentum is 0, so final momentum will also be 0. Okay, so and velocity of center of mass, initial velocity of center of mass is 4 into 3 into 4 plus 4 into minus 3 by the total mass, which is 0. So velocity of center of mass is 0 initially, and there is no external force. So velocity of center of mass will continue to be 0. Okay, so final velocity of center of mass is 0. So correct option, correct answer is 0. Okay, so only one question is remaining, which is question number 17, which we'll do in the class.